Forensics Lecture 3-2, The Significance of Physical Evidence. So beyond the analysis of the physical evidence, the primary goal of the scientist is to create an updated statistical database for evaluating the evidence. Ideally, evidence with individual characteristics is wanted, but evidence with class characteristics is much more common. And because of that, databases are key to the analysis process. There are limitations to physical evidence, however. The significance of physical evidence is really left up to the jury. And the jury is made up of lay people who are not specialists. And due to the high esteem that society holds scientists to, the analysis of the physical evidence carries a great weight for the jury, becoming a primary factor in either reinforcing or overcoming doubts about guilt or innocence within the trial. So because of how high of esteem that they hold them to, if there is not proper safeguards put into place, it could unfairly prejudice a case against an accused or for an accused. Using physical evidence, the number of different objects can link an individual's involvement to a crime. The more objects that link them, the more likely they are responsible for the crime. But it can also exonerate or exclude suspicions on an individual. If evidence is found to be different from the standard or reference sample, then that individual has to be excluded. Scientists' task is to find as many characteristics as possible to compare one substance to another. Significance is decided by the quality and composition of the evidence, case history, examiner's experience, in which they draw the conclusion, and it can range from speculation of a situation or to near certainty. With modern analytical techniques have become so sophisticated and sensitive that natural variation in an object becomes almost infinite. If scientists were to carry the natural variation to an extreme, no two things in this world would ever be alike. For instance, if we looked at the density and refraction index when comparing two pieces of glass. With latest techniques, we can distinguish if the glass originated from a single pane of glass, which goes way beyond what the investigators want to know, which would be something like they came from the same window. If in the same stream, if we looked at a paint chip under a microscope at a magnification of 244 times, as opposed to 1600 times, the more detail, obviously, that higher magnification is going to show, no two chips are ever going to have the same properties, even if they came from the same car. So criminalists must define limits of natural variation among materials when interpreting data. So using the lower magnification is sufficient for the needs of the investigator. Evidential variations are not the same as natural variation. Distinguishing evidential from natural variation is not always an easy task, but comparative examinations can be conducted as a less revealing magnification, like I had said, but it's more meaningful to the investigation. So that fine line has to be determined by the criminalist, the investigator, the analysis. Forensic databases are the ultimate contribution of criminalists make to linking a suspect to a crime. Current databases are dramatically altered or have dramatically altered the role of crime labs during the investigation process. They allow labs to actually take an active role in identifying the suspect. They're no longer bystanders waiting on investigators to bring them the information. We have fingerprint databases referred to as AFIS. It's Integrated Automated Fingerprinting Identification System. It's a national fingerprint and criminal history system maintained by the FBI. It compares the prints to 500 million prints that are already on file. The process that takes place is once the fingerprint is deemed suitable, the examiner creates a digital copy of the print, uses a computer coder to help him mark the points on the print, and then submits that to AFIS. They'll then receive a list of potential candidates that they can fine-tooth comb go through the comparison. In the DNA database, it's referred to as CODIS, Combined DNA Index System. It enables federal, state, and local crime labs to exchange and compare DNA profiles electronically. And it actually contains 3 indexes: forensic, DNA database, and this is DNA evidence from unsolved crime scene evidence. It's based on a match. Police from multiple jurisdictions can identify serial crimes, allow coordination, and share the leads developed independently. The offender DNA database, which is DNA profiles of convicted individuals. The arrestee DNA samples of awaiting trials. This database actually had constitutional issues that arose, but resolved in the Maryland versus King case, which decided that any individual arrested with supported probable cause must give a buccal or the cheek swab. And it was determined that this is a legitimate booking procedure, just as if fingerprints photography are, and it does fall under the Fourth Amendment, which is the right of people to secure their home, persons, property, and effects against unreasonable search and seizures, and shall not be violated, and no warrant shall be issued except upon probable cause. And there are, the DNA that is from these people who are awaiting trial. They haven't been convicted, but having them on file is not a bad thing in the wider scheme of things of building the database. But with this acceptance came the need to analyze swabs very quickly. And so what was developed was called a rapid DNA, and this processes the DNA in 90 minutes to come up with a profile, and these profiles are then put into the DNA databases. However, there's still hundreds of thousands of samples that are backlogged, waiting for analysis and submission to the data. So there's still a lot of work that must be done. In the ballistic data, there is the National Integrated Ballistics Information Network, or NIBIN. It allows firearm analysis to acquire digitized and compare markings made on bullets and cartridge casings. The Integrated Ballistic Identification System, IBIS, is who actually captures the images and puts them into the server. And then the examiner's job is then to analyze the list of candidates that are generated by the database system. In paint databases, we have the International Forensics Automotive Paint Data Query, or PDQ, and it contains chemical and color information pertaining to the original automotive paints, information such as model, year, assembly plant that the car was made, and this is used mostly in hit and runs. And then we have the impression database, and this actually contains 2 databases, but it's shoe print image capture and retrieval, SICAR. And the first one is Soulmate, and this links crime scene shoe prints to manufacturer. And the second one is TreadMate, which houses tire tread patterns for comparison for the investigators. And then lastly, we have the Missing Persons Database, National Missing and Unidentified Person System, or NAME-US, and it's a repository and resource center for missing persons and unidentified descendant records. It's comprised of 3 databases: missing persons. The system will check new cases against data for any matches that they may come up with. The unidentified persons database, which consists of people who have died and their remains have not been identified. And then the unclaimed persons database. And this is a deceased person who has been identified, but there's no next of kin or any family members that have been identified or located. This ends 3-2 lecture. There will be a quiz next class.